So you pretty much read it off. And how do you, tell me in English how you find the average of a set of data. And let me write it down, sorry. Okay. So you add all the data points.
Divide that number.
Divided by, what do you say?
How many points are there?
How many?
Or how many, numbers.
Or the number of data points, right? Alright, so we all know that. You add them all up, divide by how many there are, right? That's a quick definition of average. What algebra is shorthand for all that. I don't have to write that definition out. I'd rather give somebody a formula, and we have to understand what the symbols mean. One of the most used symbols in statistics is a symbol that goes up with this idea. Add them all up, right? So they decided to use, incredibly enough, the Greek letter S for sum. So to add them all up, so let me put an average. Add up is this symbol. And who knows what that symbol is? It's the Greek letter S. It's also known as sigma. Cool, right? So if you have any idea about fraternities or sororities at colleges, sigma, right? So you often see that symbol as a part of their Greek letters. Okay. What do you think I use for all the data points? That's the same thing I've used forever to represent all the possible values. X. So add up. This symbol by itself makes no real sense. It's like an unfinished sentence. Add up all the... So it doesn't make any sense by itself. Add up all the data points. And what letter should we use to represent the number of data points? N. I didn't lead you at all. All right, cool. This is our first little equation. And this is for, let me make sure we understand, this is actually for a sample. We've got to make a distinction between a sample and a population. Because the letters we use change, but sometimes the formulas themselves change if I have a sample or a population. The symbol we use for average is X bar. And really, the bar is the main part of that. So you read this exactly like that. You read that as X bar. Cool. I'll tell you what, I'm not going to have this on because somebody pointed out that people can't see too well. All right. In case anybody wants to do that. So real quick word about population. So now we all know that this symbol means sum up. Actually, let's take a side note here. Let's get some data and try this formula out directly real quick. Just to make a point about something. So say this is my data. 1, 2, 3, 4. Now, I don't want you to feel like this is what stats is going to be, making things that are easy more complicated. That's not true, right? This is simple. Finding the average is simple. That's why the formula, we really don't use it directly that much, because it's easier just to do add them all up, divide by how many there are. I just want to get you used to one thing here. X bar would be the sum of X over N. Well, what's the sum of X? Yeah, so if you add them all up, you get 10. So that's going to be 10. So replace that with what it is, divided by N. And it's 4 numbers. Beautiful. So once you get used to replace that whole thing with 10, you can't plug anything in for X, because what's X? Several things. So you can't plug in for X. You want to sum up the X's, right? Replace the whole thing with 10. N is how many there are. There's 4 of them. Not because that number's 4, but there's 4 things. And that, of course, would be 2.5. Yeah. Are you all right? Who has a clue what this might mean then? So here the sum of X is 10. What would this mean? And what would I do to get it? What does this say to do? Square square 10? That would be this. That's 10 squared. That's 100. Square the sum. What does it say? Sum up the squared x's, right? Do I have the squared x's yet?
No.
So of course you got to get them. So I'm trying to get you ready for the formulas that are coming. They're going to say sum up this mess. You got to get this mess first, and then you can add them all up. People keep trying to plug stuff in directly into the equation. You can't do that. You got to get what it needs and then add them all up first. So this says sum up my x squares. I don't have them yet. So let me get them. 1, 4, 9, 16. What do you get when you add those up? 30. 11. And then you can do whatever the formula says to do after that. So in statistics, it's very heavy on concept. But the nice thing is there are definite formulas related to those concepts, and it really just becomes plug and chug. If somewhere in an equation it has this in it, now you know you just plug a 30 in place of this. If it has this in it, you know to plug 100 in the place of that, right? The concept comes in to tell you which formula to use when. You have to understand the concept to know where to go. Okay. So that's pretty, hopefully, straightforward. That's our first little foray into statistical formulas. The only difference with the population and I kind of disagree with the book here, but that's going to happen every now and again. I don't disagree with this. Instead of x bar, we use the symbol. You guys ready for that? That's a U with an extra leg. That's not an M. But if you make a little M, that's okay. But it's a U with an extra leg, and it's a French cow, basically. It's mu. Right? So I'm trying to make it stick in your head. So the way to say that letter is mu. So it's Greek letter mu. That's the symbol for a population average. You'll notice that a lot of population symbols are Greek letters. A lot of sample symbols are our letters, right? You see that a lot because Greek letters make it sound more formal. That would be a whole population. So the formula for it, the one little thing I disagree with the book is they put a big letter in, and you can maybe imagine why they put a big letter in. Because it's a population, ooh, but it's still the size of the damn thing. I would still use a little n, but they have a big N, whatever. All right? It's still the size of whatever the hell you're looking at. Okay. How are we doing so far? Yes?
So you said that's a U or an M?
It's a U with an extra leg. So make a U with an extra leg. Yeah.
But if we like on the test or something, we put the heavy on the
I'm fine. I know what you mean. That's fine. We're going to have several Greek symbols that we're not comfortable with because we haven't grown up with Greek symbols, most of us. Some of you guys might have. But you just make them, you make it up, down. There you go. And it basically looks like an M, so what the hell? I'm with you on that. As long as you know it's not an M.
What if it's more like a W? That's how mine looks.
Well, that's something to work on.
Yeah.
If it looks more like an M, I'm better with that. The W, no. I can't work. All right. By the way, this section is all about what's called measures of central tendency. I love the use of so many words. It's just, where the hell is the middle? Is an alternate title for this section. There are many different ways to identify the middle. So most of the time when you read the paper, just to get a little, no, this is fine, this is the next thing. When you read the paper or you watch the TV, what do you ever see when they talk about home prices or they talk about incomes? They almost never talk about averages. What do they keep referring to? Like the something home price is going up, the median home price. All right, so the first question is, what the hell is the median? What is the median in the road? What is it?
The middle,
The middle.
regardless of
So
how much is on either side.
Well, not regardless, really. It's got to be the same amount on each side. It's got to be. So the median is the number that's right in the middle of the data. in order for it to make sense, though, there's something missing from that definition. So let me give you a quick example. So it's the number in the middle of the data when something. So let's try to figure out what that something is. So here's some data. 2, 7, 5. That's my data, right? Example 1. Is the median 7?
No.
It can't be. That wouldn't be fair, really. It would not be fair. There just wouldn't be any reason to have an idea of median if it could be whatever order I want it to be. So it must be the middle number when the data is in order. Right? We're in the middle of the data when the data is in order. Otherwise, I can make the median any damn thing I want it to be. Just rearrange the data. Look, the home prices are going up. It's magic. No, screw that. Moving numbers around, it's not going to make anything happen. So 275, you got to first put it in order. So the median here, of course, is 5. And the symbol we use for the median is X with a tilde on it. So it's like an X bar that's had a rough weekend. All right, so that shows you there's two definite different ways to get a feel for the middle of data. Why do you think we use the median when we talk about income and home prices? Exactly. So, for example, a really good example, let's look at salary for a second. Say there's a new guy coming into the company, and there's 5 people that work at the company right now. And this is in the thousands of dollars, right? This is income in thousands. You can spell maybe, Jeff. There you go. 40,000, 50,000, 80,000, and then 500,000. Who's this? The boss. Great. So the new guy says, how much money can I expect to make when I start working here? Are you going to give him the average income? Is that going to give him a realistic expectation of what to expect? Hell no. Why? Because the average includes this data value. The average is affected by extremes, right? Let me write that. It sounds like a note. Note. The average is affected by extremes. Extreme values. If I made that number 600, 800, 900, 10,000, does the median change? What is the median right now? How would you find it? It's supposed to be the numbers in the middle. What number's in the middle? Neither one of these. It's the number that's in the middle of those two, right? So what number's in the middle of those two? 65. How do you find that? You just take the average. So if I have 3 numbers, it's easy. The number in the middle, let me not flick you guys off, is the number that's in the middle. If I have an even number of numbers, I got to average the 2 in the middle. The number in the middle of the 2 in the middle is in the middle. Right? Think about it. If it's in the middle of these 2 that are in the middle, it's in the middle of the whole damn thing. There's just no other way. So there's only 2 possibilities for the median. It's either a data point or the average is the 2 in the middle, right? If you have an even number, you get an average. If you have an odd number, there is a dude in the middle, right?
Let's just add them and find them by 2.
Exactly. So to find the median here, 50 plus 80